Today we're going to talk about linear or nonlinear functions. We're going to be looking at this mostly from a table, but you are more than welcome to graph these things to see what's happening with them, and then we're going to also build in some of our other vocabulary terms that we've seen in the past as well with this unit. So if we have different graphs here, let's say, wasn't very good, but that's okay. Linear, what does a linear function look like? Linear has this word line in it, so it's going to be a line. It doesn't necessarily have to look like this where it's going downhill, but it is something that it needs to be a line. And by definition, that means straight, okay? So it shouldn't have any curves to it. It could go straight up and down, it could go left and right, so it could go vertically, it could go horizontally, and things of that nature. But every single line and every single member of the linear function family is going to be in the form y equals mx plus b. That m is going to be important. M, that stands for slope. So this means that the slope must be consistent between points. So you can't go up by 2 for one jump and then go up by 1 for another jump. That just doesn't happen with linear functions. So nonlinear then is anything that doesn't meet that qualification, that it goes up by the same amount every single time. So one example of this could be something like that. That's nonlinear. That's not going to create a straight line at all. Here, if we have one more graph, something looking like this, okay, that's not linear as well. Now these have to be functions, okay, so let's refresh our memory with what that means in terms of a graph. It needs to pass the vertical line test. So if we're looking at these, here's our vertical line, yep, that passes. This passes, this passes. If this parabola was faced on its side, would that be a function anymore? No, because it would fail the vertical line test. So it does need to be a function, meaning that x values can't repeat or it needs to pass the vertical line test. Okay, so this is kind of our break line here. This would be an example of a linear function, and over here are non-examples or our non-linear functions. Okay? So let's take a look at this. Again, we're going to see these in terms of a table, and we're going to look at these building in other vocabulary words that we've had. So, all right, here we go. We have this table of information. It has 4 different points in it. And so we have the point -2, 0, 0, 2, 6, 8, and 10, 12. And the first thing we're finding is this a function, yes or no? So looking at the x coordinates here, none of those x values repeat, so yes, it is a function. Okay, we're going to skip over for right now linear, nonlinear, and slope. Those things go together. Let's refresh our memory down here, domain. So remember, we're going to list those in fancy brackets, least to greatest, not repeating any numbers, and those are the x's. So we have -2, 0, 6, and then 10. Okay. Our range is going to be our y values, and again, those are going to be in fancy brackets, listed in order from least to greatest, not repeating any numbers. So 0, 2, 8, 12. Already in the proper order, we just have to use the correct notation for them. Okay? And then x-intercept and y-intercept is what we just got done dealing with. So here, anything that's an x-intercept is going to have a y-coordinate of 0, meaning we're looking for that y value of 0. So our x-intercept here is -2, 0. And a y-intercept is going to have an x-coordinate of 0. So 0, 2 is our y-intercept. Okay? So that's all stuff that we've done in the past, building it in with this. The last piece to deal with, or the last piece that we're going to deal with here, is the slope, linear, nonlinear, and slope. Okay? So slope, I'm actually going to bring this over here. So slope is the change in y over the change in x. And so it's rise over run. Change in y would be your rise, and change in x would be your run. And so we're going to look at what that looks like for each of these things. So we need to first figure out what the change is going from each of these down. So from -2 to 0, we're adding 2. We're going up 2. From 0 to 6, we're adding 6. And from 6 to 10, we're adding 4. We're going to do that same thing for the y's as well. So you could do either order. So 0 to 2, we're adding 2. 2 to 8, we're adding 6. 8 to 12, we're adding 4. Okay? So for each of those things, we're going to look at the change in y over the change in x. So for these first 2 points, the change in y, the slope, the change in y was 2, and the change in x, it was also 2. So that means that the slope between those 2 points is 1, or 1 over 1. The next set of points, our change in y was 6, our change in x was also 6, which simplifies to be 1. Last thing, we have the change between these last 2 points being 4. The change in x's for those last 2 points is also 4, which means 1. So here we have the exact same slope, okay? The exact same slope. So since all of these are the same, it is linear. We could connect these points with a straight line. So we're going to circle linear, and then our slope is that consistent thing that we got, that 1. If 2 of them have the same slope, but the third one doesn't, is that linear? No, they all have to have the exact same slope to be consistent, going and changing by the same amount each time. Okay, so keep that in mind as we go as well. All right, so let's take a look at another one here. So we have, again, another table that we're dealing with, and we are going to find all of these things, okay? So is this a function? 1, 3, 1, 10. Did we repeat ourselves? Yeah, this 1 repeated itself, so this is not a function. And if we were to graph this, so I'll show you on this one, you can kind of sketch. So we would have 1, 3, and 1, 8. So 3, 5, and then 10, and 12 would be up here somewhere. So that is not going to be linear whatsoever. So we would say that this is non-linear. Okay, it doesn't make a straight line at all. So if it's non-linear, it doesn't have any sort of slope for you to answer. So we can just X that part, and then our domain is the X values from least to greatest, not repeating in fancy brackets. So we have 1, 3, 10, and then our range is Y values, again, least to greatest, fancy brackets, not repeating any numbers. So 3, 5, 8, and 12 would then be our range. Okay, we're going to look at one more of these. So we have these values, these points to deal with. So is this a function? So 1, 3, 4, 6. We didn't repeat ourselves, so we're going to say yes. Linear, nonlinear, and slope, we have to do some extra steps, extra work. So let's go on to domain here, because that's easy to complete. So we would have 1, 3, 4, 6. And range, we would have 1, 9, 16, 36. So keep in mind, it's not always the case that these are perfectly in order for you. You might have to do some rearranging as necessary. All right, so for linear, nonlinear, we have to have a consistent slope. In order to count that, we need to know the change in y over the change in x. So we're going to calculate all of the different changes here. So from 1 to 3, we're adding 2. 3 to 4, we're adding 1. 4 to 6, we're adding 2. Just because those aren't the same doesn't mean that this is not linear. Okay, so let's keep going. From 1 to 9, we're adding 8. From 9 to 16, we're adding 7. And from 16 to 36, we're adding 20. So to figure out our slope, we need change in y over change in x for each of these, and we're going to see if they're consistent or not. So change in y of the first 2 points is 8. Change in x is 2. 8 divided by 2 simplifies to be 4. So if all of these are 4s, we're going to say linear. If all of them aren't 4s, then we're going to say nonlinear. Well, if we move on to the next one, we have change in y is 7, change in x is 1. So 7 divided by 1 is 7. So right here, we automatically know that we should be saying nonlinear. Because all of them so far aren't the same, it's not linear. Okay? We could even go to that last one. Not that it really matters, but we would have 20 divided by 2, which would give us 10. So since all 3 are not the same, it is nonlinear. Okay, so keep that in mind. If it's nonlinear, we also don't have a slope. Change in y over change in x, all of those things need to be consistent for this to be linear.